Welcome back to Daily Stand-Up. I'm going to show you all how to set up a Fanout exchange in RabbitMQ to basically allow you to create really powerful and sophisticated systems that operate using multiple queues with the same messages, so you can register multiple consumers and have parallel paths in your system operating at the same time with the same message. So let's get into this. So the first thing that I want to show you is the exchange that I have set up in RabbitMQ. And the exchange is two Shirk engines, front end, controllers, Fanout. And I'm using Mass Transit, so Mass Transit uses the namespace by default, so that's why you see that. But the name of the exchange is this. And you can see that the type of the exchange is a Fanout exchange. A Fanout exchange you can think of as, just visually something fanning out, meaning that this exchange, when you publish a message to this exchange, the message will get routed to anything that's bound to it. And it doesn't need any routing key. It doesn't matter what's routed to it. It's going to get routed to anything that's we have set a binding to. So in this particular instance, I have two queues that are bound to this exchange. And what that means is that both of these queues will get the same message. And I'm going to show you that right now. So I'm going to go ahead and go to Postman. I have an endpoint set up that I'm going to send data to. I just have a JSON objects, data, and then test data. So I'm going to go ahead and send that. This is the endpoint that we have set up. It just publishes the message up to RabbitMQ with Mass Transit. Let's go ahead and step through that. And let's go back to RabbitMQ. Back to the exchange. You're going to see in about 5 seconds, you can see the publish in and publish out metrics have changed, indicating that we received a message, and then we have just routed it to our exchanges, or to our queues, excuse me. So if we go to queues, and Fanout 1 and Fanout 2 are the queues that we have bound to that exchange, you can see that we have one message ready to be acknowledged in both queues. So if we go to Fanout 1, we go ahead and get that message. You can see that our message is right here. So message test data. So that's Fanout 1. If we go to Fanout 2, you can see that if we get a message, you can see that we have the same message in a different queue. We go back to the exchange. Down here, you can see that the setup is very simple. All it takes is we can add a queue right here, and we can give it a name. So actually, let's go ahead and bind another queue to show you how easy this is. So the first thing you want to do in RabbitMQ is, if you're adding another queue, if you go to queues and streams, we'll go ahead and add a queue. Oops. Let's give it a name first. We're going to call it Fanout 3. So I don't have a virtual host set up. The type is, I'm just going to do a default. Name is going to be Fanout.3. Durable is set to durability is set to durable, meaning that if for some reason my server crashed or I killed this container of RabbitMQ, everything would persist. And that's what we want. We don't want the queue to be torn down or deleted. So that's all we're going to set. We're not going to set any arguments. We're going to go ahead and add that queue. So now we have Fanout 1, 2, and 3. Fanout 3 has identical configuration to Fanout 1 and 2. So if we go back to the exchange and we go to our Fanout exchange, if you go down to the bindings section here, you can just set up another binding. So if we just use the name of the queue that we just created, we can bind to that queue. And the next argument is asking for a routing key. It's not required because a Fanout exchange doesn't need a routing key because it sends a message to anything that's bound to it. This will change depending on the type of exchange that you're dealing with. If you're using a topic exchange, that will require a routing key, I believe, because it needs that key to know what queue to send that to specifically. And some people get creative with how they name things, because you can you can basically add pattern matching to decide what queue you send it to. It can get really complicated, but we're not going to do any of that because fanouts are really easy. So all we're going to do is set to queue, fanout 3, and then bind. So now we have fanout 1, 2, and 3 set for the queues that are bound to this exchange. So let's go ahead and send another message up to this exchange, or publish a message up to this exchange. We're going to go ahead and send, and let's look at our exchange. We're going to see that publish in come in a second. Okay, and if we go to the queues and streams, you can see that fanout 3 now has that message. And obviously fanout 1 and 2 will have 2 messages now ready to be acknowledged because we had sent a message to them previously. But now that's all we had to do. And we have just added a queue that gets the same message off the exchange. Now we have 3 queues that can be consumed from whatever we want. If we register a consumer in our .NET app, it could read from fanout 1 and let's say post the data to the front end. Then we could register a whole other consumer to fanout 2 that could post that data to the database. And then we could register another consumer off of fanout 3 that could manipulate that data and, I don't know, post it back to another queue. It doesn't matter. And you can do all that in parallel. And that's a very, very powerful thing you can do in a system, especially if it's an existing system, because if you have an existing flow that you don't want to mess up because it's, maybe it's already in production, you have users, you can just create an exchange of type fanout, and then now instead of just one-way data flowing through your existing system, you can set up a two-way data flow. That way you can introduce in parallel a whole system that you can develop on and build and not have any impact to production at all. And that's very, very powerful if done right. Now, obviously you can mess that up. You can create, if you're in a really, really high throughput environment, obviously introducing exchange will, it will have some overhead associated with it, but it's very negligible. But if performance is something that you're serious about, you may need to look up like performance charts and graphs based on the types of exchanges and just see if that's right for you. But I would say that, assuming you're not sending, 10,000 messages per second to RabbitMQ, you're probably fine. I think I saw a performance chart realistically, and a fanout exchange was still around 400 to 4,500 messages per. How low was it? I'm gonna say this so wrong. Is it per second? I think, because when we tested locally, the system here that we've been building on the channel for the past year, we were getting throughput rates of just about that per second because we sent 500,000. I'm gonna forget now. We capped at about 500,000 messages a minute, I think. I can't even remember now. We got to a million in about a minute and a half, which is just wild. I think if I remember right, I have to go back and watch the video. But this is a super powerful thing you can introduce in your system. So if you're wondering how you can basically add a whole new path and not have to worry about anything being disrupted in production, this is one possibility. Queuing technology is very, very powerful. The AMQP, the Advanced Message Queuing Protocol, is very powerful, and all these message brokers have done a really nice job in making it easy to connect to systems like RabbitMQ. Very easy. And I say message broker. What I meant to say is libraries like Mass Transit have done a really good job in making this thing very accessible and very easy to implement in a system, because it handles a lot of the intricacies of AMQP in the sense that it handles acknowledgments, it handles what happens if the message fails to get to the queue, it handles retries, it handles automatic creation of exchanges, queues, it handles publishing, it handles so much for you that you don't necessarily need to know a lot about the protocol. But if you do know about the protocol, it makes interacting with this stuff that much better. It helps you understand as you're developing in something like this, because it helps you visualize kind of in your head what's happening with my message when I publish, like what is actually happening. And it's very, very powerful. And so if you're thinking about system design and you're thinking about how do you handle data and how do you create multiple paths that act on the same data, this is a viable option that you can do. And you saw it's very simple to set up, once you have all your stuff in place. It's very, very powerful. So I would definitely try to experiment with it, test with it. Again, I don't have a lot of stuff running to make this happen. I have a Docker container running with RabbitMQ. I have a .NET API running, and that's it. I mean, it's crazy how you can make some really, really powerful stuff very quickly. So let me know if you want like any kind of like diagram or architecture diagram kind of outlining any of this. And I think on the next one, we might register multiple consumers, so that way we can see the complete, path that, we took from actually sending data or publishing data to our exchange, routing down to the queues, then being consumed or received by our registered consumers on our .NET app with mass transit. So maybe that's what we'll do next time, and you'll see how we can create different paths, doing different things with the same data. Really, really cool. And at some point, I'd like to do more performance benchmarking with RabbitMQ and post that in the channel. If you're curious about what performance we've seen in the past, I set up a system to use SignalR, so WebSockets, with RabbitMQ, .NET, React, all that stuff, and we sent like 1.5 million messages at it, and we saw the performance of that. And in short, it was insane. If you want to see that, go back and look at that video. We also have a Rust microservice connected to that, and it was processing data off RabbitMQ at just unbelievable speeds. It was ridiculous. So if you're also interested in that, we can do another recap of that. But this entire thing, I want to throw into another system design video where we kind of walk through that. Maybe we'll do another system design interview or mock interview, kind of diagramming, something like that. But this is the stuff that I find really, really fascinating because of how powerful it is. So I'll see you on the next one.